So let's start our lecture 2. Okay, so today's lecture is all about squeezing and how it using the sigmoidal functions to our logistic regressions. So let's take why we using these sigmoidal functions. Why we need to use this kind of sigmoidal functions, and what is the main problem in the our logistic regressions, and how to need it. So first let's discuss about the previous class, what we have learned it. So we have two type of data points. So let's take our one kind of data point is all about white, and let another kind of data point is about blue. And we use this the yellow line as the separator, that is in higher dimension case we call it as hyperplane. So let's take this hyperplane is pi, and the perpendicular of this plane is w. Okay, so this is the one plane. So as we see, such kind of there have many kind of planes, but at the end of the day we have to find the best plane that separates perfectly to our different type of data points. So there may be another planes like this may be one plane, this also may be one plane, this may be one plane. So there are many plane, but we have to choose the best one among these. Okay, so if we write it as mathematically, what we have derived the mathematical equations of it. So we derived it as w star, it is equals to arcmax of what is the summations of signed distance. I is equals to 1 to m. Let's our data point number of data sets in the training set is n. For the signed distance, that is yi w transpose xi. Okay, this is the our distance of the point from the plane, and total is the signed distance, and this is all about our optimization problem. Okay, so here we have seen there have many planes, and according to S plane there are many w. So let's write down, we have one plane is pi I, and of this plane we have wi. Okay, and now at the end of this day we have find the best w star, that is optimal w, which we will call the best, yeah, optimal w star. Best or optimal w, we denoted it as w star. So if we write yi carry our two types of value. One is +1 and another one is -1. For one class point yi carry +1 and another class point yi carry -1. Just bear with me, now we are just only discuss about binary classifier. Okay, and in the later of this chapter we will learn how to, using logistic regressions, how to we build a multi-classifier. Now just patience with me, we are just learn binary classifier. Okay, yi carries two values for +1 and -1. So we assume +1 is for positive class and -1 is for negative class. And total distance, this total distance, we call it as signed distance. Signed distance. And one thing we have to remember, that here W transpose xi is nothing, just it is a distance from xi to any plane that we have assumed. So let's take one plane, that is pi. And one thing, if yi W transpose xi, this, if this one is positive, then we conclude that the pi as defined by W, pi which was defined by W, is correctly classified to our data points xi. So pi as defined by W correctly classified our the data points. Say let's take xi, and if it is negative, that implies that it is incorrectly classified xi, that is data points. So simply incorrectly classified xi. So till now we have learned the previous lecture. So now let's take what is the motivations of this lecture. So now let's draw. Let's take an example. So we taken an example. Let's draw a picture. We have taken one class level, that is we have using the blue ink to denote this class level, and we using the pink ink to denote the another class level. And the separator, the best separator is we denoted as yellow line. Okay, and let's take this plane is all about pi 1, and the normal vector of this plane we, okay, and the normal vector of this plane we call it at w1. Okay, and the distance, and let's take edge distance from this point is all about d1, this which is nothing, so simplicity just we have taking it as d, not sorry, just think what happening. Okay, just simplicity, we have taken it as d is equals to 1. So edge distance we have taken, the point each appears here such a way that edge distance is equals to 1. Okay, and the similarly edge distance from this point to this plane is also is equals to 1. Our this distance is also is equals to 1, and this distance is also is equals to 1. So we have taken this example to discuss this situation. Okay, so in case 1, so let's call it as case 1. In case 1, pi 1 is my separator. Okay, pi 1 is my separator, and corresponding to pi 1 we choose w1 as the normal vector, perpendicular to the plane pi 1. So at the end of the day we calculated the summations. I is equals to 1, I to something, how much points we have. Suppose let's take, we have n, yi w transpose xi. What is the total distances? Now as we seen that the pi 1, if the point, if the directions of this one is equals to this one, and if the plane is correctly classifies this point, if the plane is correctly classifies this point, okay, so if it is correctly classified, that is d, and we know d is what about w transpose xi, and is all about, for all point it is all about 1, and it is correctly classified, so the multiplication is equals to 1, and we know denoted that this is also is equals to plus 1, this is also to plus 1 plus 1 plus 1 plus 1. So first we write down one thing, it is equals to plus 1, and for pink color we denoted is as minus 1. Okay, so what is all about this distance? This distance is negative, and this one is also this side of the plane, and actually this is also correctly classified, and this is also correctly classified, so this is also minus 1, and a distance is also minus 1. For blue point, just drop here with me, for blue point this one is equals to plus 1. For pink point, what will be the distance? This distance will be equals to minus 1, because the directions of the w1, sorry, here will be 1, and this number will be 1, minus 1. Okay, because the direction equals to 1. So this one is final, at the final calculations we arrange this is minus 1 for this point, and the multiplications also minus 1, so final it will equals to plus 1. Similarly this point it will also plus 1, this point it will also plus 1, this point would also plus 1, and this point it will also plus 1, and show the what will be the total distance. So find positive, that is 1 plus 1 plus 1 plus 1 plus 1. Okay, 5 1, and now for negative ones is your plus 1 plus 1 plus 1 plus 1 plus 1, because our plane is correctly classified. Okay, positive point as well as negative point, so all are positives here. Now let's take another twisted is here. Now let's take our point is this side is all appear our negative point, and that shows the situations of negative point is here. This is our negative point, this is appears here. and the distance of this point from our plane, and the distance of this point from our plane, let's take this distance for this plane is equals to d is equals to 100. Okay, so what will be the situations in such scenario? So our distance from this point is equals to, from our plane is equals to 100, and the point is also misclassified. Actually this point is negative and the directions of is equals to positive. Direction is positive, here is all about positive point, but the point is negative. So in such situations, so let's take this point is about x dash. Okay, we call this point is x dash. So for this point we use the different color. So for x dash, what will be our d? D will be our W transpose xi, and what it is actually W transpose, actually this distance is plus 100, and what is the actual value? X dash is negative, that is yi here is equals to -1 and distance is equals to +1, and it is totally misclassified. We know if misclassified then yi into xi into w transpose will be negative, so here it is negative -100. So what is the final value if we consider our outliers? Actually this point is our outlier. Okay, so what is the, if we consider the, in this case if we consider the outlier, what is the final situations? So final value will be 10 minus 100, that is equals to -90. So at the end of the day, if we consider this value is equals to 90. Now let's take case 2. Okay, so I think in this picture, if we draw this picture clearly to another window, then so one thing is that what is the actual accuracy of this model? So how many points we have? 5. So we use a different color. Actually we have 5 positive point, 5 negative point, and 1 negative point. This 5 positive point is clearly classified, accurately classified. These 5 negative points is also accurately classified, but this negative point is not accurately classified. This is misclassified. This is the main problem. Okay, so accuracy of the model is all about we have correctly classified 10 points and 1 point is misclassified. In total 11 points we have correctly classified 10 points. Okay, so we have 11 points, and in 11 points here we have correctly classified 10 points. So our accuracy is equals to accuracy. Our accuracy is 10/100. So now let's consider the case 2. Okay, so this before discussing the case 2, so just draw this picture. Draw the same picture. Here we have using blue ink for one data set of data points. We have using pink ink for the another set of data points. and we have using pinking for the outliers. This one is our outliers, and in case 1 we draw our planes like this, but here no, we draw our planes will be this will be our plane. So in such cases, what will be the situations we have seen? So let's take this plane is all about phi 2, okay, and the perpendicular to this is equals to this one is equals to pi 2. This is one plane, and the w directions of the normal of this vector is all about w2 case 2. So case 2 our plane is pi 2, and for this pi 2 we have the normal plane w2 according to this direction. So if we consider these points, these points, these 10 points is the one side of the plane, and this point is the another side of the plane. Actually this is our outlier, okay, this is our outlier. So if this is this kind of the plane, let's take this distance is equals to 1, okay, and from this point to from this point this distance is all about 1, from this point to from this point this distance is all about 1, similarly rest of the others. So similarly for the negative points, this distance is also from the plane is equals to 1, and from each point distance is also 1. Okay, so now the main thing is that what is the signed distance of this? Actually this is the positive points and this is the negative point, okay, and positive point is correctly classified, so this value will be +1, this value will be what, +2, this value, actually why +2, actually w transpose xi is positive and di is 1 for this, so positive +1 into +1 is +1 +1 into 2 y2 actually di d2, so we have written here d1 is equals to for case 2. So in such situations for case 2 d1 is equals to 1, d2 is equals to 2, d3 is equals to 3, d4 is equals to 4, d5 is equals to 5, and if this is the correctly classified point, positive points, okay, and if positive points is correctly classified, so it will be positive, so positive +2 and d3 what is all about +3, what is all about +4, what is all about +5. Actually end of the day for blue point for case 2, just bear with me, blue points we write down this concept, actually yi, sorry not yi, okay, positive points +1 into the distance di, okay, positive point is what, on positive yi is all about +1 and distance is all about 1 2 3 4 5 6, so this one. For pink points, what is all about, pink point yi into di, and di comes from where, from here, and what is all about yi is equals to -1 into this one, di is coming from here. So this value for ping point, this value will be -1, -2, -3, -4, -5. Okay, now let's take our outliers. What is all about our outliers? Outliers, if we see the outliers, that let's first take the distance. So let's take this distance is equals to d is equals to 1. Okay, if this distance is equals to 1 and this point is the different side of the plane and this is also negative, okay, different side of the plane and this is also negative, this means this is correctly classified. If this one is correctly classified, then what is the value of this point? This point, the value will be yi into di. Yi is -1 and it is yi is equals to -1 and this is also different side of the plane, that is also this. So actually this point is also -1. Okay, what is final is the 1. Okay, so at the end of the day, if we calculated this value, so what is all about summations I is equals to 1 to n yi w2 transpose. Here we have using w2 transpose x. What is the value? That's +1 +2 +3 +4 +5. That is -1 -2 -3 -4 -5, and for outlier we have got it as +1. For outlier. Okay, so what is the final value? This value cancel out, this cancel out, all these are cancel out, and only value we have got 1. Okay, so what is the accuracy of this point? In previous case we got the accuracy 10 by 11, and what is our, so let's write down clearly. So what is our positive point here? So 5 positive point, 5 negative point, and also we got our 5 1 negative point. So here in this plane, this is correctly classified. Okay, positive direction. This is also correctly classified because it's another direction, negative direction. But the main problem is all about this. This is not correctly classified. This is not correctly classified. Okay, if this is not correctly classified, so what happened? Accuracy. So in this case, our misclassified point is equals to, correctly classified point is equals to 5 plus 1, and total point is equals to 11. So accuracy is this model is equals to 6 by 11. So this is our accuracy in case 2. So what is the best accuracy? If we choose the two cases, what is the best? So our main motto is finally maximize our the find of the sum. So since +1 is greater than -90, Okay, the our intuitively, what do we choose? We choose intuitively this pi 1 is better than pi 2. Actually, if we geometrical shown here, intuitively pi 1, actually case 1 plane is better, accuracy is better, it's and accuracy is better here, case 1. Okay, but in case 2 accuracy is lower. But we see that the summation value for case 2 is greater than the summation value signed distance, summation value of the signed distance in case 1. So this is the main problem. So in such situation, we got the main problem. This is our main problem. Okay, case 2 summed value will be greater maximum from the case 1, but we see that our accuracy case 1 is better. Okay, so as mathematics, as logistic equations, we got pi 2 as my classifier. But pi 1 is better than pi 2. Intuitively if we see, pi 1 is better than pi 2, but our mathematics shown that pi 2 is always classified. So this is one kind of contradiction. So to avoid such kind of situations, what we have used such techniques, this is called our squashing. So why squashing we have needed? So for outlier, so why we squashing needed? For one single extreme point, that is outlier. So for one single outlier, point is changing my whole model. One single outlier totally changing my whole model. Okay. So changing whole model, what it actually mean? Changing whole model. Changing whole model, if we summarize, changing whole model means our hyperplane, affect our hyperplane. Effect on our hyperplane. Okay. This is very bad situations. This is very bad situations. So actually max of signed distance, max summations of signed distance, max summation of signed distance is not outlier phone. This actually end of the day we have calculated this maximum of summation of the signed distance. This is not a very outlier phone. Not a outlier phone. Okay, so to avoid this, we're using squashing technique. So let's start the squashing technique. What is squashing? Okay, so the main idea behind this squashing. So what is the main idea of this squashing technique? Idea idea is mean that instead of using single distance, instead if we here actually what happening, actually at the final of the day we have used the sign distance to sum it up, and after sum it up we have taken the maximum sum signed distance. Instead of using signed distance, if sign distance, if we just using some conditions, so let's write down the conditions. What is the conditions of the sign distance? Instead of using the signed distance, if we apply some conditions, so let's see what is the conditions. If sign distance in small, then we have used at is it, at it is. If the signed distance is, if the signed distance is very large, then we try to make it smaller. This is the main condition, and let's see how we make this larger distance to smaller distance. So clearly write down this situation. This is the main concept of the squeezing. If the distance is small, just take it as it is. If this distance is large, then we try to small this distance. Okay. If our signed distance is small, then use as it is. And if our signed distance is large, then make it a smaller distance. Make it the smaller distance. This is the main primary key concept. Okay, nothing else. This is the key concept. So let's try to understand it as graphically. I think that it will be better. So here we have using the signed distance. What is the signed distance at the final day? Yi W transpose Xi. So I plus infinitive minus infinitive, and this one is we have taken some functions f of some distance. We have taken here some functions, so let's take, so let's divide these portions. I think 0, it is 10, it is 100. Okay, if the point is increasing, then it will linearly increase, but after some time it will increase, then it will taper off, this. If smaller increases, this function is increases, but after some time it will taper off. Okay, not. We don't go this direction. It is not linearly. After, for smaller value it will linearly increase. For smaller value we have considered, for smaller value we have taken activities. So smaller increases, for small increases we have taken linearly, but after increases we have taper of this function. Okay, and similarly this, just write down for clarification. TAP, tapering off. And similarly for negative sides also. For smaller increases we have taken ADS linearly, then after that we have taper of these functions. So just like this. For larger value we try to make it smaller. So for larger distance we have tapering of this function, and for the smaller value we have taken considered as linear. Okay, so that's function of this slide. So at the end of the day we have using this, just write down. What final optimization, what our final optimizations problem, arcmax of W and summations of I is equals to 1 to n, and again I am telling that n is the number of data points of our training set, yi w transpose xi. Okay, this is our mathematical problem. And after outlier effect, what do we have changed this function? These functions is now changing as arcmax of W summations I is equals to 1 to n f of, here we have applied these functions. Okay, here we have applied these functions. Now after this we have seen what is the function actually. Now after this we have shown. Okay, actually this is on our signed distance. So now what is these functions? Now let's consider and discuss what is the behavior, or what is actually the functions. Just we changing our windows to this. Actually this function is nothing. If we using the Google tool, yeah, something else software we have used, just function is that this function is the 1 plus 1 by 1 plus exponential of minus x. This function is drawn through this here. Okay, just see that if the function's value, if we take the functions x is equals to all about 0, then you can see the value of the y is all about 0.5. Okay, just see it, just see the slide, just see this slide. If we take the x value is equals to 0, then y value is all about 5. If increases, it will increased, y value is increased, y value is increased, and after some time it will, y is all about constant at taper off. Okay, all is all about. Similarly for negative directions also. Okay, just write down the behavior of this model, of these functions. Okay, so if we call it as sigma x, okay, so what is the maximum value of this? This is the maximum value. And what is the minimum value of this? This is the minimum value, 0. So maximum of these functions is equals to 1 and the minimum of these functions is all about 0. And what is the pi of 0? Pi of 0 is equals to 0.5. So we have seen it here. This is the pi of 0 and this is all about 0.5. Okay. And this distance is all about our signed distance. So just compare these situations with our model. Actually, at the end of the day, if we changing the color, just a minute, if we changing the color, actually end of the day, we have our plane. This one is all about plane. This is called pi. Okay, and this is the perpendicular to our plane. If the point is lie on the plane, then what is all about distance? So actually distance is nothing, W transpose xi. If the point lies on our plane, this one is equals to 0. If the point lies on the plane, then we cannot conclude it is actually positive point or negative point. So in such situations, what will happen? In such situation, we have seen from this picture, if the distance is 0, then signed distance what? Then signed distance also equals to 0, because actually signed distance, what do we have? No, signed distance is equals to nothing, yi W transpose xi. If this one is equals to 0, then total distance is equals to 0. Then pi of 0 is equals to what? That is half. That is, its probability is equals to half. If it is lie on the plane, then the probability is equals to half. It will be positive or negative. So both probability will be the same. Okay. So probability of our point is equals to positive, or at which call is 1 is equals to half. Similarly, probability of yi is equals to negative, or it is called -1 equals to half. Both probability are same. And if we see, if the sign distance is very large, and if we see if the sign distance is very large, okay, just see it. If the sign distance is 12, if the sign distance with then the probability is 0.999999 something, that tends to 1. If sign distance is increased, then probability is maximum. Okay. So if we write it, if W transpose xi, that is very large, then what are this sigmoidal function? What this function if large, then the sigmoidal functions try to minimize these as close as to 1. So then probability of yi is equals to 1 is equals to 1. If this distance going larger than larger, then our functions try to minimize is as closer to 1. Okay, so now let's go back to our main window. Okay, so at the end of the day, what happening? At the end of the day, we got that our W star is equals to arc max of W summation of sigma. What actually F is nothing, previously discussed sigma. So summations of 1 plus 1 by exponential of, so simply exp functions means expx means e to the power x. Just don't be confused about it. in programmatical standpoint of view, we have write exp of x means exponential of x. Exp of x of what? What is our functions? Sigma is equals to 1 plus 1 by a to the power minus x, that is a to the power minus yi wi, sorry, w means w transpose, don't write w, xi transpose. This is our final equations come. So this actually the benefit of this function, it is the less impacted by the outliers. This function is actually less impacted the outliers. So if the outlier points is appear here, we try to minimize it. With distance, try to minimize it. This is the main concept. So if we conclude this, the maximum sum of the sign distance is what? Maximum sign of this actually what? Actually because of outliers. We got the maximum sum of the distance, sign distance is about outliers. And now we have applied here our sigmoidal functions. And sigmoidal functions, this is all about sigmoidal function. And sigmoidal what it has done? Sigmoidal, it is tapering off and linearly separable function, tapering off, it is linear and easy to define probabilistic function, simply probabilistic proof. This is the probabilistic functions. So why, if we are a mathematics student, then you can arise a question. Simple. Sir, this kind of behavior, there are many kind of functions. But why we have chosen these sigmoidal functions? The main reason is all about why we have chosen these functions. Why we choose it? You can ask questions. So there are many such kind of functions that behave like such kind of scenario. But why we have chosen this? So because it is easy to differentiate simply, and probabilistic interpretation, easy to probabilistic interpretations, because it first we have considered because it is easy to differentiate. Easy to differentiations. Number two, probabilistic behavior. For these two main reasons, we have chosen these functions, and easy to discuss. And this is the main reason why we have chosen it. So in this two lecture, just we have concluded the two lectures. Then what we have actually seen. Okay. deriving logistic regressions. But now we have just using geometric intuition. Now we have just discussed is about geometric discussion. Okay. Now in the next lectures we have seen about its probabilistic interpretation. And at the end of this series of lectures, we discuss the loss functions based logistic regression. Okay. So now we have just discussed all about geometric intuitions, and middle of this series of lectures we have discuss all about its probability interpretations, and the end of this lecture we have discussed about the loss function based for logistic regressions, and we have discussed it in details. We have discussed details. Probabilistic intuitions we have discussed in briefly we have discussed, and logistic based steps we have in details. Just patience with the series of lectures, and just follow the series of lectures. We have discussed about totally in details, and we have given some pointers, references, how to, why, from where we have learned in details the logistic regressions, and what kind of research paper we have to read to understand better and best method of logistic regressions in better way. Okay, and we have learned some references. Okay, thank you for your patience. Just see the simple concepts. Just take a real case scenario and simple real case data. Just compare with this with logistic regression. It is as simple as you think. Okay, thank you. We have seen you in the next lecture. Okay.